Talking about inverse functions today. Okay, basically an inverse function is a function where the x and the y values switch places. Okay, so like if my first function is y equals 2x plus 1, or f of x equals 2x plus 1, I can find the inverse by switching the x and the y. So f of x is like the y value, interchangeable. So if I switch that to an x and then that to a y, this is the inverse function. To change it to function form, I should get y by itself. How do I get y by itself here?
Subtract 1
And divide by 2. So you can divide the whole thing by 2 or each part by 2. Okay, anyway, 1/2 x minus 1/2. Or to put it in function notation, so the inverse functions look like a little -1 up there. Okay, so if the original function is f of x, the inverse function is called f inverse of x. Let's graph these and see what they look like on the graph. See if you guys can guess what the pattern is. So the first one was 2x plus 1. So you go up 1, slope is 2. You guys remember how to graph those? Second one, slope is, or y-intercept's -1/2, slope is 1/2. So up 1 over 2, down 1 back 2. Alright, make it a little bit longer. How are those two related to each other? They are reflections over this diagonal line, y equals. This diagonal line is the line y equals x. So if the y and x switch values, they flip over the line y equals x. So for example, right here there's a point at 3, 1, right? And on this graph, there's a point at 1, 3. So you see how the x and the y switch places? 3, 1, 1, 3. Or where's another point? Well, it's kind of the same thing. This is 0, -1/2, right there. This is -1/2, 0. See, the x and the y values switch places. And they look like reflections over this diagonal line, y equals x. Alright, that's mostly it. Alright, here we go. Number 1, these are going to be easy peasy Japanesey. Ready? Okay, it says for each relation, listen. For each relation, represent its inverse as a set of ordered pairs. So if number 1, if the function they give us has a 0.15, what's the inverse function going to have? Push here. Yeah, you just switch the x and y value. So instead of 1,5, it becomes 5,1 on the inverse. And instead of 6,2, it becomes, and instead of 7, -4. Okay, are you guys getting warm?
Yes.
Yeah, Mr. Tokyo and turned you up.
That's probably the problem. Who wants to close that vent?
That's good.
Hey, Trevor, you might actually be able to reach it without a chair.
Not all of us are.
It'll still be warm. It'll still be
You're also
warm.
not the one who always get the cold air from
Oh, crap.
Cold air shouldn't be on.
that. It's barely
Primary
right
rinse.
Yeah. Okay. Number 3. So, what does the number 3 mean?
You just switch which spheres there.
Right, so the first point is basically -3, 15. Do you guys see where I got that from?
Yes.
So what's it going to become?
15.
15, -3. just drawing, giving you a visual aid, I guess. Second point is 212, so 2. And the third one is 412, so 4.
So wait, if they match up to 2, like if 1 matches to 2 on the right side, would you just write, I'm just gonna say it, I'm doing number 4. So it'd
just
be
do it
2/3
backwards.
and
You can
1.
figure it out. Just do it backwards. Okay. By the way, is this a function right here? Number 3, what we just wrote? No. If the x values repeat, you guys remember this? It's been a while.
Oh, yeah.
It's not a function, but if you look at the original thing, it was a function.
Yeah.
So the inverse is not a function, but the original one was. So sometimes that happens. Number 5. Duplicate the graph. Okay. So we need the graph paper. You're supposed to copy. You're supposed to copy the graph that they drew. So
We gotta do B.
it's just the heater. It's just the heater. A's at -3, -1.
For 2 and 4, do we have to do B?
Oh, that's right. It did say that. So number 3, I said it, but I didn't write it, and actually it was a question. So this one, the inverse is not a function, so we're supposed to put no. Is number 1 a function?
Yes.
Yes.
Yeah, it is. Okay. Yeah, do be. Put yes or no.
So it's a function if the x's are different.
If the x's are unique, yeah, it's good. But if they repeat, like on number 3. Okay, B is at -4, 2. Are you guys graphing these? Don't wait for me to do it, just do it yourself. C is at 1, 3.
No, well, we're not.
We're supposed to graph the inverse. I don't think they said you had to, but I'm going to go ahead and draw this diagonal. This is, they did in the book. Okay, I can't tell in my book because they did it in the same color that they put the answer, so I didn't know. Okay. All right. If A is at -3, -1, where is its inverse point going to be? -1, -3. Does that make sense? So A was at -3, -1. Come on. So its inverse point is at -1, -3. Notice it like A jumps diagonal. So and the way they label it is they put a little apostrophe. It's called A prime. Different to differentiate it from A. I don't think you need those. If you look at it, A is like one diagonal move away from the diagonal line, as A prime is one diagonal away. So, okay. B is at -4, -2, or +2. -4, 2. So where is the inverse point going to be? Right. It was at -4, 2, so the other guy is going to be at 2, -4. So where are we?
Do we need to write that line down in the middle?
What are they listening to?
Mr. knows Mr. Black.
It's like boom, 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 boom.
It could be someone from this day.
Okay, so C is at 1, 3, so C prime is at 3, 1.
This is easy.
Easy peasy, Japanese. Wait, yeah, you jinxed us. Wait till we get to the B section.
No.
So is the diagonal line this way always going to be the
Yep.
way we're correct on?
So on number 6, my advice is just do each vertex and then connect the dots. There will be some overlap, because their dots are on both sides of that line, there will be some overlapping triangles. But just reflect each vertex, like do what we did with these points, but you just have to connect the dots on number 6.
Okay.
That's the only difference. All right. Vertex just means the corner. Just do the corner points and then connect the dots. Okay. Number 7, find the inverse rule.
Isn't it just kind of like,
Okay. It says f of x equals x plus 1. F of x is like the y. You remember what I said at the beginning? Basically, you just switch the x and the y. So it's x equals y plus 1, and then just solve this for y.
do we graph these or
How do I get, no. How do I, not this section. How do I solve this for y? Minus 1. So y equals x minus 1, or you could say f inverse equals x minus 1.
You're right, I did Jeeves.
No, it's not hard. If it's hard, you're not looking at it right.
Well, okay, what does f of x mean? Does that just mean y?
Yeah. It's interchangeable with y,
Then
yes.
why'd you move the x to the y? Like, how did you do that?
You switch the x and y value to find the inverse function. And solve for y. Number 9. Q of x equals negative 1/2 x. Okay, what do I do first? Switch the x and y. So x equals negative 1/2 x plus 1.
Do I have to put that thing at the bottom where it says f minus 1x equals x minus 1?
Yeah, f inverse of x. This, yeah, let's go ahead and write our answers like this. It's good practice for us. All right, how do I solve this one for y? How do I get y by itself?
plus minus 1?
Okay, minus 1. X minus 1. Then how do I get rid of the negative 1/2?
Divide.
Divide. How do you divide by negative 1/2? It's the same thing as multiplying by negative 2 over 1. So multiply by negative 2. Everything gets multiplied, like this whole side gets multiplied by negative 2.
This doesn't make sense.
On this side, those go away. So we have negative 2x plus 2.
Where'd you get negative 2 from?
I just was talking about it. You divide by negative 1/2, which is like multiplying by negative 2. So, yeah, that's it.
So then, why on this one did you not flip the x and y?
I did. I did, right here.
I mean, the second time, because you did it twice on that other one.
No, I didn't. Did it once.
You did the x minus 1, and then the minus 1 on the other side, and then y on the other side.
Oh, I just... Doesn't matter what side it's on.
When you swap the x and y's, you don't take the number in front of it? You don't?
No, just swap the x and y.
Okay.
Alright, number 11. Find the rule, that's what we were just doing. Then graph the function and its inverse on the same coordinate plane. So it's like combining five, well, yeah. Kind of combining the two, graphing in, find the rule. H of x equals negative 4x plus 1. Alright, so how do I find the rule? The inverse. Spot the x and y. So x equals negative 4y plus 1. Subtract 1 to get y by itself. Y by negative 4. I'll put it like that. So what is this going to become? What's x divided by negative 4? Negative 1. Negative 1/4 x. What's negative 1 divided by negative 4? 1/4.
So why did you add that 1x over 4 to the left of the negative 1 over negative 4? Why is
I mean, why did I switch the order?
No, like go up that thing right there to the very, very left.
This?
No, to the very left.
Oh,
Then, yeah, 1x over negative 4. Why is
x
that?
divided by negative 4 is like 1x divided by negative 4, so it's negative 1/4 x. It's like invisible 1 right there.
But, okay. So why is there two things on the left side of the equals?
Two things on the left.
Like there's the negative 1 over negative 4, and then there's the x over negative 4.
I'm dividing both sides by negative 4. Divide both these by negative 4.
Is that one whole number on the left side?
Huh?
Is that one whole thing on the left?
One whole thing. X minus 1 are two different terms. I could have written it like this,
That's what I was.
but the problem is when we go to graph, that will be confusing. So I split it up. Both of those are divided by negative 4.
Okay.
We've done this before when we were graphing like linear functions. You can divide them individually.
So no one needs graph it.
Yeah, we're supposed to graph both the original and the new H inverse function. Anyways, okay. So, the first graph, the first function, where am I going to start at? Up 1. Where am I going to go from there? Down 4, right 1. That's the slope. Or you can go backwards, up 4, left 1. Should be on the same line. Now if we did it right, our second line should be a reflection over that. Okay, where am I going to start the other thing at? Up 1/4. Pretty low. And then where am I going to go from there? Negative 1/4, so down 1, right 4. So down 1, right 4. Notice I'm not on the intersection of those lines. I'm still a fourth off of this line. Or if I go backwards, up 1, left 4. Kind of missed.
That one has 0
Hmm?
It's not 1/4, 0 1/4.
So if you do it right, you should look like you could fold it over the line y equals x, this diagonal line, and it should look the same on both sides. Alright. 13, oh boy.
Don't we say if it's a function or
Oh, does it ask that?
Yes.
Alright, is it a function?
Yes.
So graphically you can tell if it passes the vertical line test, it only crosses through at one point. And it does only cross through at one point. 13. Okay. This one looks slightly easier. G of x equals negative x plus 4. Alright. What's my first step to find the inverse function? Switch the x and y value. So g of x was my y value. Now it's my x value. X became y. How do I solve this for y?
It just became what?
Solve for y means get y by itself. So it says y equals. How do I get rid of the negative? Divide by negative 1, which makes this a positive y. And these will switch to negative and positive. Divide by negative 1, switches to negative. So my g inverse function is negative x plus 4. Does that look familiar?
Yeah, I was saying.
It's original function. Let's see what it looks like on the graph. Alright, how do I graph negative x plus 4?
Not 4.
Start up 4, and then where do I go from there? Invisible 1, so it's down 1, right 1. Okay, why is the function and its inverse the same thing?
Because it hits the line of
Okay, yeah, if you fold this diagonal over this diagonal, they are the same. So it's a reflection of itself over that line. Or if you look at the coordinates of these points, like this is 3, 1 right there. 1, 3 is right here. It's, that was kind of sloppy, Joe. There we go. All the inverse points are on the same line as the line itself. So basically anytime you have a slope of negative 1 on a line, it's going to be its own inverse. Oh boy. Ooh. Oh, is it a function?
Yes.
Yep. It's a function because it passes the vertical line test. If I draw any vertical line, it only hits the line once. So it passes. It is a function. Number 15. H of x equals x minus 2. Well, okay, what do we do first? Switch the x and y. So x equals y minus 3 over 2. Yeah, then we can, to get rid of the divide by 2, we could multiply by 2. So if I multiply by 2, that just goes away. Then what? Plus 3. So if I plus the 3, y equals 2x plus 3, or h inverse equals 2x plus 3. How do I graph this original function?
Two different.
Yeah, if you divide both of those by 2, so it's in like slope-intercept form, this would be 1x, so 1/2 x minus 3 halves.
How do you get -1 at the bottom? It says h -1.
That's the notation for an inverse function.
So it's always
If this is h of x, this is its inverse, h inverse of x. Yeah, I've been putting that on all of them. Okay, so the first equation, where are we starting at? Where's -3/2 at? 3 divided by 2 is 1.5. So it's down 1.5, right there. Where am I gonna go from there? Rise 1, run 2. Okay, the other one probably easier. Where am I starting this at? Up 3. How do I fix that? Let me. And the slope is 2, or 2/1. So up 2, right 1, or down 2, left 1. That's bad. There we go. Nailed it.
Oh, wait, I just don't get why we have to write the h and x thing. Why can't we just do
This is just a way of saying this is the inverse function to that.
Do I have to write that in the problem code?
Yeah, let's go ahead and do it. It's not that hard. I mean, if you want to skip a step and just write it right there, you could have done that. You could do that.
That makes more sense. That thing right there.
I just switch it to y and x to y because it's easier to work with. Just a y then. Okay, I don't know if I can fit in. Oh, is that a function?
Yes.
Yeah. All these lines are functions. The only exception would be like the inverse of like y equals 2 is x equals.
In their function, because they cross, right?
On 16, there's no x.
No, we plug it in. And then-
Oh, that's the example I was just talking about. I think let's just go to 18. It's gonna take a while.
I'll drop a couple. The person doesn't do anything.
All right. Okay, on 16, it just says f of x equals -3.
Y equals -3.
That's like saying y equals -3. What does the graph of y equals -3 look like?
Down 3.
Horizontal line.
Or you go to -3 on the y-axis and draw a horizontal line. Okay, well, if I switch the x and y value, what's it going to become?
X equals -3.
X equals -3. So, there's no way to write, you can't write f inverse in that case. It's kind of, this is a weird one. X equals -3, you just go to -3 on the x-axis and draw a vertical line. Is x equal -3 a function?
No.
No. It fails the vertical line test because it hits at all these points. So that's a no. 16 is a weird one. Alright, 17. Also kind of weird because it's an x squared. So this is new today. G of x equals x squared minus 3. What shape does an x squared graph take?
Parabola?
Parabola, right? How do I figure out what the parabola looks like? What's the minus 3 going to do to the graph? You guys remember that?
Move it up 3?
No,
Or
down 3. There's a down 3. So, yeah. Anyway, I'm kind of getting ahead of myself. I need to find the inverse function first. So I'm going to switch the y and the x.
How could you just get rid of x? Oh no, because it doesn't g, the x thing equal.
G of x is like the y.
Yeah.
Okay, now how do I solve this for y?
Add 3.
Add 3. This kind of goes back to last chapter because how do I get rid of the, well actually this might be an older chapter. How do I get rid of the square? Square root, but something happens when you do a square root of both sides. Okay, plus or minus happens. What day did we do the square root of x? Friday? Or Friday before last?
Oh, Friday before last we did a test.
Friday before last was the test?
Last Friday was the test.
Yeah, last Friday.
Yeah, so it was Friday before last then. Anyways, you guys remember what graphing square root of x looks like?
That'd be, where's it?
No. No. Square root of x, this is not the answer. It looks something like this, remember? Oh, revelation. Okay, what does the plus 3 do to the graph?
Makes you go to the left.
Left 3. Anyway, this is kind of a mess to graph all these. Oh god. So I guess let's start with the x squared minus 3 thing. The vertex, the graph is just shifting down 3. So if I plug in 0 for x, I get 0, negative 3. That's the vertex of the parabola. Okay, if I plug in, let's say 1 squared minus 3 is negative 2. If I plug in, let's say 2 squared minus 3 is 1. So we can use these points to help us graph the parabola. 0, negative 3, 1, negative 2, 2, 1. You guys remember how we did parabolas? Like, what am I missing here?
They're just mirrors.
You mirror the image over the vertex. So there's a point there and a point right there. Oh boy, I missed. Swing and a miss. Just a bit outside. Okay, there we go, that's better. Okay. So here's the thing with the square root. We got y equals positive square root of x plus 3, and we also got y equals negative square root of x plus 3. What do you guys think the negative is going to do to the graph?
You have to
Upside down.
Flip them. So x plus 3, the lowest x value you could plug in for that is negative 3. Because remember, it can't be negative, the square root can't have a negative value. But if we put in negative 3, that plus 3 turns it into a 0, and that's okay. So anyway, negative 3, 0 is a point, negative 2,
Couldn't you just?
1, huh?
Like, what would you swap the x and y?
Yeah, you could kind of cheat and swap the x and y values on this. That would work. I want to show you kind of how this works though. Do you see what she's saying here? So like on this one, we got the 0.21, so that means
Oh,
on this one there should be 1, 2. It's probably easier, but I kind of want to show you guys something. And if I plug in 1, I get 2, which I kind of just mentioned. So negative 3, 0, negative 2, 1, 1, 2. Okay, does that look familiar? Guess what happens if I plug in all these numbers to the other function? Okay, you get the same thing, but it's upside down. It's a vertical flip. So individually, this thing and this thing are functions. But together, is this a function, the blue thing?
no.
No. By itself, the square root of x, that's a function. Or square root of negative x, or negative square root of x. This is a function. But together, it fails the vertical line test. So it's not a function. So, no. That last one's a doozy. Don't skip it. I'll make it worth a lot.
19?
18. So it starts off pretty easy. The first half, you know, pretty fast. The graphing slows us down. Huh? 16, yeah. And I did 16 already, so that'll help.
Was it 16?
This was 17, but right before this I did 16.